my name is Ebony Monson and I'm from Trobe University, and my FameLab presentation is entitled, How Can We Boost Our Immune Response? Now, with the latest lockdowns happening across Australia, it's hard to forget the devastation viral disease can cause. However, just as a reminder of the devastation just one virus can cause, as of yesterday, 3.9 million people have died of COVID-19, with a further 180 million people being infected. And that's just one virus. We still have viruses like dengue virus, which cause 96 million infections annually. Now, usually our bodies fight off potential viral invaders with several layers of sophisticated defense, otherwise known as your immune response. Not only is it designed to seek out and destroy invading viruses, but it also remembers the ones it has encountered, so they are swiftly dealt with when they return. Viruses, however, have developed sneaky ways to disguise themselves and can mutate to avoid detection. What is so scary is that the active and frequent mutating nature of these viruses has deemed most antiviral treatments ineffective. Therefore, it is imperative that we understand how the early immune response works in order to manipulate it to fight viral infections more effectively. And that's where my research comes in. The early immune response consists of intricate signaling pathways comprised of many key antiviral molecules. My research looks at where these antiviral molecules are located within a cell. The localization of these molecules to certain structures in a cell can improve the speed, intensity, and stability of an antiviral response triggered by invading viruses. I work on a droplet structure called lipid droplets, which we hypothesize act as a place for these molecules to come to during an antiviral response. My research has demonstrated that these droplets increase in number during an antiviral response, a phenomenon which is needed for an effective immune response. However, unfortunately, it alone is not able to provide protection for an infected cell, where we get viral dominance leading to the death of the infected cell. However, if I increase the number of droplets to prime these cells before infection, these cells have a heightened immune response and they're actually able to go on and clear and survive the infection. Now, to better understand what molecules are associated with these droplets, I designed techniques to extract these droplets from cells before and during an infection and have pinpointed key antiviral molecules that localize to these droplets, most of which have never been reported before. Now, this is really exciting because it means that during an infection, these droplets are creating regions of high immune signaling activity. And now that we're beginning to understand what molecules might be associated with them, they're creating a region desirable for us to target new antiviral drugs to. COVID-19 is the most well-studied viral disease in history, and it, along with many other chronic viral infections, still have no antiviral treatments. My work in understanding the key mechanisms underpinning the immensely intricate immune signaling pathways is key to the development of future antiviral therapeutics that target our immune response to boost it. Thank you.